Welcome viewers, in this video we will see the 3-phase induction motor direct online starter, DOL starter. There are 5 type of starter available and one type is direct online starter. In this video we will see the working principle of direct online starter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the topic. So in a low capacity motor, that is less than 5 horsepower, the starting current is not high. So the main objective of starter is to reduce the starting current taken by the 3-phase induction motor. In order to avoid the damage, we need to limit the starting current. But in case of low capacity motor for this 5 horsepower, less than 5 horsepower, the starting current is not very high. It is already it is lesser. So they can withstand the starting current without any starter. So in case of low capacity motor, without the starter we can start the motor because the starting current is lesser. So there is no need to reduce the voltage to control the starting current, right. To reduce the starting current, the starter will reduce the voltage applied to the starter. When the voltage reduces, automatically the starting current also reduces. So here the low horsepower motor, no need to reduce the voltage. So they use a starter which connects the stator directly to the supply. So in this type the supply is directly connected, no need to reduce the voltage. Our aim is to reduce the current, we need to reduce the voltage in this, but it is not needed without reducing the voltage, hence it is called as a direct online starter. So due to this objective, due to this low capacity motor, the supply is directly given to the motor without any reduction, so that it is called a direct online starter. But though it does not reduce the voltage, it will protect the motor from the overloading and low voltage. The other advantage of this method is either we are connecting directly, but there is a facility available is we can protect the motor from overloading and low voltage. Now we will see the diagram. By referring the diagram, so the stator is available, stator winding, so slip ring is there. There is a 3-phase AC supply is available. So this is a fuse, for protection purpose fuse is there. Then thermal overload relay is available. During overload or during overcurrent, then more current will be drawn. At the time this thermal overload relay will be cut off. In order to protect the overloading, we are using the thermal overload. So it is available. Here one the energizing coil is available, magnetizing coil is available. Here we have 2 contactors available. NO means normally open, it is normally in open condition. Here NC normally closed condition, always in closed condition, right. So due to this normally open, the supply is not given to the magnetizing coil, it is in a open circuit manner, right. So in order to start the motor, we are pressing this normally open contact. This normally open contact is closed. So that what will happen? The supply is given to the magnetizing coil. So this magnetizing coil, due to the voltage applied to the magnetizing coil, it is energized. So it will attract this contactor. This contactor is attracted, so that the supply is directly given to the stator. So initially yes, NO is in open condition, NC in closed condition. Due to the open condition, the supply is not given to this magnetizing coil, it is in a de-energized manner. So in order to start the motor, this NO is closed. So while closing, the circuit is closed, the supply is given to the magnetizing coil. Due to that, it become energized. Due to the energized, it attract this slip ring and the supply is connected to the stator. Now the motor is applied with the rated voltage. Suppose if any abnormal condition is there, we want to disconnect the supply, this NC is open. If you open the NC, what will happen? This magnetizing coil is, the supply is not given to the magnetizing coil. The supply given to the magnetizing coil is cut off. So that it is de-energized, and so that it will release the slip ring, so the supply is disconnected during abnormal condition. And another facility available is overload or overcurrent. Suppose in a normal operation, if any overload or current is taken means this thermal relay will be cut off, so that it will disconnect the motor from the supply, right. So I will explain again. So the 3-phase AC supply is available, fuse is there for protection purpose, thermal overload relay available for the to protect the overcurrent. This is the stator available, is connected through the slip ring. One energized magnetizing coil is available. This contactor is always in closed condition, this contactor is always in open condition. So the during the starting, this NO is closed, so the coil is energized, it will attract the contact, so the 3-phase supply is given to the stator winding. So the motor will start at the rated speed. If we want to stop the motor, we can open this NC, this contactor NC is open, so the supply given to the magnetizing coil is disconnected, so it becomes de-energized, and so that the supply is disconnected from the motor is disconnected from the supply. If the motor goes for any overload or overcurrent, the more current is taken by the motor, the temperature increases. Due to that, the thermal overload relay will cut the supply to the stator winding, so that it will protect from the overload or overcurrent. Now we will see the description. Normally open, NC means normally open, NO means NC means normally closed. So at the start, NO is closed for a fraction of second, due to which coil is energized and attract the contactor, and so the stator is directly given supply, right. When NO is closed for a fraction of second, coil is energized and it will attract the contactor, so that the stator is given to the supply. The supply is given directly to the stator. The additional contact ensure that as long as the supply is on, coil gets the supply and keep the contactor in the on position. So the supply is given through the magnetizing coil, so it is always in energized condition, so keep the motor in on condition. Suppose if you want to disconnect, then when NC is pressed, normally closed, the coil circuit gets open. While pressing the NC, the circuit is disconnected, the coil is disconnected, so due to this the coil get de-energized, so the motor gets switched off from the supply. Due to de-energize, the attraction will gone, so the contactor will disconnect the supply. So this is another method. If you want to disconnect the supply from the motor, we can press the NC. Apart from that, an overload, the current during the overload, the current drawn by the motor increases, so the heat is produced, so which increases the temperature beyond the limit. So during the overload, more current will be drawn by the motor, so due to that heat is produced. So the thermal relay is available, thermal relay get open due to the high temperature, so protect the motor from the overload condition, right. So during overload, we are using the thermal relay to disconnect the motor from the supply. So in this video, we discuss about the direct online starter used in the 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.